The idea of the comparison test is that you take this series, which we haven't dealt with before, compare it with something that we have dealt with before, and see, is this one bigger than the one that we know about, or is it smaller than the one we know about? Well, to get an idea as to what we should be using, what I do is say, well, this one right here, you can approximate that by using just n on top, because that's the most powerful term. Adding 3 isn't really going to add that much into the problem overall. The same thing here, just use n instead of n plus 5. So we could say the original series and for the moment I'm leaving the limits off because I don't really need to know exactly which numbers it is, I just need an approximation. So this is approximately the same as having just n on top and just having n squared on bottom instead of the plus 3 and the plus 5, which if you reduce that, that is 1 over n. And then this, very famously, is a divergent series. This adds up to infinity, which you could do quickly with the integral test if you just integrate 1 over n. You will get the natural log function, and it doesn't even matter what you put here. What matters is, since all of these series go to infinity, you'll have to have infinity up here, and then the natural log function does go to infinity. So this one diverges, or in other words, it adds up to infinity. So since this one, the problem we were given, is approximately equal to that, it's approximately equal to infinity, well, that means it equals infinity. So my guess is that it diverges. Now what you do with the comparison test is you say, well, if I could show that instead of approximately equals, I could show that this series is bigger than or equal. Well, if this one equals infinity, the 1 over n, which it does, if that adds up to infinity, and our given series is actually bigger than or equal to that, then it has to be bigger than or equal to infinity, which means that it's equal to infinity. So then we have to say, is n plus 3 over n plus 5 squared bigger than or equal to 1 over n? So we're dealing with just the individual terms right now. We're not saying add them all up. We're just saying, as a sequence, is this sequence of fractions going to be bigger than this sequence of fractions? Now what we need to do is do some algebra to find out for what values of n is this true, or is it true at all? If we do the algebra and it says something like, well, this is going to be true as long as n is less than negative 12, well, it starts at 0, so less than negative 12 is not even possible. That means that this question would be no. The answer to this question would be no. It's not bigger. But if we get something and it says, okay, as long as n is bigger than or equal to 0, then that's exactly what we need. N bigger than or equal to 0. So let's continue to do the algebra. So cross multiply, and we get n squared plus 3n is bigger than or equal to 0. Multiply this over here and multiply it out is going to be n squared plus 10n plus 25. The n squares are going to cancel, and you could move the 10n over here, so negative 7n is bigger than or equal to 25. And then divide by negative 7, n would have to be smaller than or equal to a negative 25 sevenths. So this is saying n has to be negative numbers, which is not true. So then what we do is say, well, maybe they're close. Maybe for this one, instead of using 1 over n, I was supposed to use 2 over n, which would still diverge because if 1 over n equals infinity, 2 over n is going to be twice as big, so twice infinity. So what I would do at this point is take a look at the graph. So here's the original one. The window could be from, let's say, the first 10 terms, and they're going to be small, so 0 to 1. Let's see if that works. Actually, let's see, this would be a half. Actually, let me change this to maybe a 0.3. Okay, so now I can see what's happening with that function. Now compare that with 1 over x. The graph of 1 over x. So the function that we're dealing with is actually smaller than 1 over x. So let me change this out to, say, 25 terms. Is it always going to be that way? They're getting pretty close. So according to this algebra, they do not intersect. But I'm just wondering if, what about if so this function right here, I need to shrink it down so that it's underneath, or in other words, this one needs to be above that one in order to make this bigger than or equal to work. So what about if I tweak this one and I insert a 0.1? So this function right here is the problem that we were given. This one now is below it. So in other words, if I go back to this and I use a 0.1, then the one that we're given right here is bigger than this one down here. So the one down there is the 1 over x, except it's 0.1 over x. Okay, so now we've got the comparison that we need. So we then need to do some explaining. So this idea with 1 over n didn't quite work out, but we can tweak it a little bit. Notice that 1 over n adds up to infinity. So if you multiply this by a 0.1 on both sides, on the left-hand side you would have the sum of 0.1 over n equals, and then 10% of infinity is still infinity. So then what we need is to redo the comparison. So we've got 0.1 over n adds up to infinity. Then redo this over here, and we would have is n plus 3 over n plus 5 squared bigger than or equal to a 0.1 over n. Okay, again, cross multiply. I'm going to need to continue that on another page. Cross multiply, we would get n squared plus 3n on the left side, n squared plus 3n, and then we would get 0.1 times n squared plus 10n plus 25. So if you multiply this out, we're going to have you know what, instead of dealing with these decimals, what I could do is multiply both sides by 10. And then that will get rid of this 1/10 right here. So 10n squared plus 30n, is that bigger than an n squared plus 10n plus 25? And I think I see the quadratic formula coming. So we would have 9n squared minus 7n minus 25. Is that bigger than or equal to 0? So quadratic formula n is going to be negative b plus or minus the square root of b squared. So that's going to be 49 minus 4 times a times c, and then divided by 2 times a. So let's see, this is 949. 7 plus or minus the square root of 949 divided by 18. So we've got 7 minus the square root of 949 divided by 18. So as long as n, oh, another thing I could do is graph this, and I could have done this instead of the quadratic formula, but you could say 9x squared minus 7x minus 25, is that bigger than or equal to 0 ever? So then take a look at the graph, and that is a parabola. Is it ever bigger than or equal to 0? So the answer is yes. So the negative 1.3, that's this one over here. Our n's are positive, so we want this one right here. So that's at 2 point something. So we don't really want the negative one, we want the positive one. So that's going to be, from this point on, yes, the parabola is positive. So 2.1 or whatever it is. Let's see, 7 plus the square root of 949 divided by 18. Okay, so for n bigger than or equal to 2.1, it's true. Now, with the comparison method, all you need is to get a statement that from some point on, the statement is true. So, the idea being, since you're going to infinity, what happens for the first two terms doesn't really matter. What matters is, as you go to infinity, what happens. So, since it's going to be true from 2.1 on, that means that this function from 2.1 on is bigger than this function, and since this one adds up to infinity, then this one has to add up to infinity. So therefore, the series n plus 3 over n plus 5 squared diverges, adds up to infinity.